positive's wired, negative's wired. Yeah, I know this ring terminal's huge compared to those ring terminals, but we should be okay. So it's wired up. Next I need to run this bad boy in and see if this thing starts up. So I'm going to try first the jumper method, see if it works. If it works the jumper method, I'm going to hijack the existing wiring and make my own switch. Okay. Woo! Okay. This is either going to short out, blow a fuse, or work. So I looked at the other system. Only these two of the three get continued. So I can take this flathead screwdriver, hold it by my rubber isolated handle only, and turn the compressor on. Or electrocute myself. Either way, you'll have an interesting time. Here we go. Or maybe it's non-conductive? Okay, got it. I had it backwards. The pop you heard was the plastic cap on the top getting launched. It's not nearly as loud as I thought it'd be. That's nice. An effort to speed up the processor, showing you guys stuff. I'm just gonna, instead of showing you guys stripping and explaining every single wire, I'm gonna do the step, show you what I did, and proceed from there. It'll help speed up the process. I mean, you guys see me strip and land plenty of wires in the last couple videos, so let's see how this goes. What are you doing, Harvey? You putting the screw in for me? Oh, that one looks pretty tight. You want to tighten this up some more?
No.
Okay. I'm doing the grounding system for the battery. So we have a battery cable here going to our bus bar. Then this is going to go down to our common ground. This is going to go to our chassis ground. So this is going to jump here to probably that stud, be a chassis ground. And this will also continue on this side. I'll take it out through this hole to the actual common ground of the whole vehicle. I decided to rerun this wire with a lot higher gauge. They don't quite tell you what's going on, but I didn't realize this is actually the common ground. So I'm actually grounding this to the chassis. So this is how it's measuring my amperage. Measuring amperage on the negative terminal with a small positive sensor. I'm blanking out the actual name of the sensor, but so this is actually my ground. My ground bus will go down to there. So this is all fully grounded. I need to do it properly. If that's lower gauge, it's going to be a choke to the whole system. Often if you have stuff that's not performing correctly, not blowing fuses though, it's probably a bad ground. This would have been a bad ground. So I have the cable, beefy ground. Tonight I ran positive to the fuse block that goes to the switch pro. I've not put the fuse in. I do not want to include that circuit yet. And for the ground, I've run a very large ground to the sensor. Then I'm going to run a 8 gauge ground from here over to down here, and I got to run some more 8 gauge stuff. So I need to buy a couple spools of 8 gauge to do what I need to do. It's currently Halloween, and I'm wearing my Catboy shirt because we're about to go trick-or-treating, but my kid's currently sleeping. So while he's asleep, I'm going to try to knock out the front plate here, the front plate over here. It should be relatively simple to do. They're relatively the same. I'm going to have a hole for the hose, so I have an air line to punch through both sides, and I'm going to have a hole for my 110 outlet to plug in on the driver's side. So I'm not going to show a lot of video of me cutting and stuff. So it's going to be cut, show, drill, show, that type of video right now. Here's a piece of plate I have. It's 1/8 inch thick. I want these to be thicker because unlike the skin for the rest of this project, this is going to be taking loads. There'll be air hoses attached to it, power lines attached to it. This is going to be an interface point, so a little bit thicker. I'm going to have it bolt onto the top. This is a strip at 7.5 inches in width. I'm going to cut this just over 14 inches wide. So what I'll do is I'll put it up there, bolt it up, and then I'll sand it down to be smooth. So I'm not going to try to make it dead nuts accurate from the beginning. I'm going to make it oversized and then grind it down. So the plate, like I said, is slightly oversized. I'll trim it down to be flush. It's squared to the top though. I'm using the factory edge on the top, side edge on bottom. I'll make a piece of 2-inch flat plate goes at the bottom behind it to join this to my actual door jamb that I'm going to make. But I'm going to have a tap up here for the airline. On the other side I'll have a tap for airline and then also for the power. So right now what I'm going to do is I'm going to drill all my 1024 clearance holes. Take this off, and with my 1024 clearance holes I drilled through, I'll drill them out for the Rivnuts. So see, I drilled the holes. I drilled a lot on the top. I want it pretty high density because that's going to be a sealing surface. Rain's going to be coming down. I'm going to make the top overhang it, so it should be relatively good there. The side I'm not too worried about. I didn't go for the corners because that's technically a hollow. Technically it is a hollow. You can see how the structure is, comes out to here, so it's hollow. No reason to put a hole there. I have now drilled and countersunk all my holes for the Rivnuts. I also added the 2 drill bits I use for the Rivnuts in the bag for them, so I keep them together. So while I've been using Rivnuts and then threading and Rivnuts and threading again, this is going to be something that's going to be commonly taken on and off if I do maintenance. If I do threaded insert, not threaded, just tap the aluminum, eventually wear out, this will be replaceable, and it'll actually wear a lot better than. Here we are, guys. Panels bolted on, really sturdy. So, pan you over this back side, you see there's overlap. So I'll do is I'll take the finger sander, cut that down. Welcome back to another day of building. Here we are. I managed to get some metal cut this weekend. I had a friend come over, he needed some help with stuff, and trade, he helped me cut some sheet metal. I didn't record the sheet metal cutting because, well, I'm respecting his privacy, didn't ask him, but there it all is, cut. So, before I get too much farther into this build, and make this thing into a monstrosity, a bunch of wires and doodads that are about to get snipped, I'm going to take one of my 3 sawhorses. Might edit that out or just let you guys have a little Caesar and throw up. Take one of my 3 sawhorses, put it in the back side, knock this lightly laid on its side, mark out and root out the bottom to start closing this thing. The last thing I want is a bunch of wires hanging low and potentially getting smashed, moving stuff around. I'm going to do that. I will then probably call it the end of the day because today's actually election day and there's going to be some shenanigans probably happening on the news and stuff like that. So I want to watch that. So let's get doing. Another thing I got, which is I'm looking forward to getting, is I've had these fireball squares. They work great. For what I'm going to be doing with this project, I'm going to need a lot smaller than that. And Fireball now has a smaller version, much smaller version. They are 30, 60, 90 triangle, as opposed to the 45, which is fine by me. But I'll be using these a bunch, I think, on this project. It's really small. I can get in here all directions, as opposed to Chungus here not really fitting anywhere in this except for the major outline squares. Not cheap, not super expensive. Right now, I think it was like $100 for a 2-pack, as opposed to, per. Laid over, I'll put the sheet metal up, mark where my parts are going to be, clamp it on, drill a couple spots, just one side to lock it in, take it down, wipe down the edges, put in the silicone, put it up, rivet on the corners, then drill and tap and rivet everything else. I'm not going to drill anything on this beam here because if I'm a little low, I'm gonna have a really, really bad day. This bottom one, I can pretty reliably do it. It's not directly against the edge here, so I should be good there. I made the box 48 inches wide, so I could just take my 4-foot by 8-foot sheet, cut pieces out of it. So this is a 14-inch strip, which, ta-da, covered, right? Now I got to mark it out, double check my dimensions, make sure I'm not going to drill a hole where there's nothing, so I want to get a good clamp. I'm going to lay this down. Get some clamps. The dogs are dumb. So, the square tube is 1 inch. I'm going to go 1/2 inch in, draw a line across. There's a reason why I'm doing the bottom first. If I make a mess of it, it's hidden. So I'm trying to do things smartly. I'm going to do, like I'm doing electrical box first, but it's not clean. I can figure out what I want to do before I commit to doing a full camper shell. Riveting, first time doing a big riveting project, I'm going to do the bottom where if it's kind of nasty, it gets never seen again. Also, I've been totally impressed with these little Amazon Basics Sharpies. They're cheap, and they haven't been doing what other Sharpies have done. They don't get the weird spots or anything. So I'm making this sheet slightly larger than I need it to be. It's not much for me to just sand down the extra and make it look really clean. I'll use that belt sander I got and put it to some pretty heavy use. I'll probably wear a respirator for that because I get a lot of metal shades. So they're relatively clean. Yeah. Let that dry. Okay. Have you ever done a lot of siliconing or sealant? Getting a little electric gun is a lifesaver. I'm just going to preemptively wipe off this monstrosity. There we go. Now I'm going to go through and mark out my spacing and go from there. 100% loving the rivet gun. That would have been a nightmare. I'd have Popeye arms going on by now. Hate my life. Honestly, that was easier than even screwing it together. Now, get to the details here. You see how this has some overhang? I'm not too worried about that because some sanding action will clear up. And I actually wanted it that way. I wanted it a little long so I can sand it down to be flush. I did the same thing right here. This is kind of a leftover technique I've done from modeling. Scale modeling, you cut the part wide and just grind it smooth and it looks really flush and doesn't take 3 years of measuring and still getting it slightly off. Well, got a floor. That's where I'm leaving it for tonight, guys. Catch you later. My right gauge wire finally came in, so it's time to start wiring this guy up. That'll let me actually charge my battery off of 110 so I can do some proper testing without worrying about slowly killing the thing. Let's get started. So even though I got the right size wire, I don't have the right size wire connected for this big old stud, so I'm going to run this larger cable down to there, then neck down to the right size cable at the bottom. It'll still hold plenty of amperage. This is the chassis ground. I'm going to run another one straight to the battery, or the primary battery, so we'll have a good ground. Okay, we got another one of those moments of truth. It's kind of like when I turn on the air compressor and it startled the crap out of me. Look down here. Actually start from here. Power ground wraps around. Power comes down to our 40 amp circuit breaker, goes down to the battery. Ground goes down to chassis ground. Chassis ground then feeds back up into the battery and goes back in just how it says. So we look over here, same thing. We'll start with the power. Power comes in through the 40 amp fuse. I'm using a circuit breaker instead. Got the battery sensor. Got the battery to the CAN bus goes to the monitor, CAN bus goes back. Also the negative. So we have a complete circuit. So when I turn this circuit breaker on, which is indicated as a fuse, this hopefully will turn on. Or not. We'll find out. Here we go. That is 100% accurate, guys. I didn't do anything except turn it on. That's the first time I've ever seen it. I'm not going to go through the menus and see what's going on with the little English thing, see what's going on with that. Okay, just got done with a very annoying setting the clock. It's very much a beep fest. So, clock set. Still calculating the battery charge because there's no draw on it, so it's not going to really know. No input, so I have no solar, no 110, no car. BMS is reading, it's reading a small trickle charge of 0.1 amp. It's probably just the monitor of this system. So stage, no charge, mode touring, 32 volts, battery temperature 69 degrees Fahrenheit. It's in. Oh, that is nerdy but cool. That's nifty. So I'm getting 32 amps in, which is perfect. So this is a 40 amp charger. So that puts, I have 0.4 amps to some sort of consumption, 39 going into the battery. So now, if I do something interesting, okay, I'm not going to bother detailing this out too much since I did another side, so now I'm going to make another panel or this side. I think I put my hoses. I'm gonna put this low, right there, my hose high. I think that'd be the best way to go about it. So now I can lay this up there, this dummy market, make it dummy resistant. On this one I'm going to drill and tap, and I'm going to go back and put a nut on the backside anyway, but that'll just help secure it for right now. I forgot to record all that, so I just drilled and tapped my 3 holes, but I put the gland back on. Oh my gosh. Okay, so I could do that again because I put the plug on backwards. I'm doing something kind of sketchy. I'm going to sand this down a little bit to make it fit better. Make it a little bit less sketchy. I chose these locations for a very important reason. The bulkhead of the back of the truck's gonna be right here, close to it, so this is gonna be relatively protected. If I have tall things, I don't have to worry about them getting smacked or knocked off. I want protection of these, so that's why they're close to the wall. That's it, guys. I wish there was more of a reason, but I thought it was a good one. I'm gonna test pressurize this thing and get a air nozzle ready so I can spray it. Here we go. Plug this in. It's in. Let me back this up and we'll do an air test. Hot wire test. So it's still on, but I've pressurized. I'm not too worried about it holding like completely airtight because it's only gonna be on for a while. I'm turning on to the run air tools, so it's not gonna be running a tank all the time. So I'm gonna do a tank. I'd make this into a 4-way manifold and bring the tap down, and probably stop here for right now so I can hose it later. So this is a moment of truth. Do it again. So I'm gonna try to stay hot wired. We have a working air system.